Hi, today we're going to be going over the Java solution for the first Leetcode problem, that being two-sum. Two-sum right here. It's very famous because it is the first question you'll see if you sign up for Leetcode. So let's go through it. So the question states that we'll be given an array of integers and an integer, that being the target. And we just have to return the indices of the two numbers that add up to the target. And we can assume that the input would have exactly one solution. And we can also assume that, well, not assume, we can't use the same element twice, and we could return the answer in any order. So basically, going through the example case, we would be given an integer array, so that's given right here, and a target. Our job is to find the two elements within this integer array that add up to the target. So in this case, you can see that 2 plus 7 would equal 9, so that's why we return a 0 and a 1. We're returning the indices of this integer array. So Java, like many other programming languages, is 0 indexed. So the first element is actually index 0, second element is index 1, so that's why we're returning 0 and 1. With this second case, this shows off the fact that we can't use the same element twice, because if we could just, use 3 and 3 again, so we could just return 0 and 0, because 3 plus 3 does equal 6, but since we can't use the same element twice, with that restriction, we can't do that, so we instead have to return the 2 and the 4. So that's why we output in a 1 and a 2, a 1 being indexed right here, which is the 2, and the 2 index is 4. This final example just basically goes over, like, just a basic solution. We could return the 3 and the 3. Those two added up equals 6. So yeah, let's get to coding. So first of all, usually in an interview, you just want to get in your ideas, and this usually means just going over the brute force solution to show that you know how the problem is sort of working, and basically getting at least an answer out there. So for our case, our brute force solution would basically just be checking every single possible combination of elements. So we're only returning two right here, two numbers. So we can just basically do a double for loop and go through two numbers, every single combination, and then check if they equal the target. So in this case, we could basically check 2 and 7. We can then check 2 and 11 and 2 and 15. Then we can check 7 and 11, 7 and 15. Then we can check 11 and 15. So we can check basically all of all possible combinations, and then see which one works, and then return that. So that would be O of n squared time complexity. Since we're basically going to use a double for loop, we're going through the array. Basically, n represents the length of the array, and basically we're going to keep iterating through it for each element, so that's why it's O of n squared time complexity. So the brute force solution would look something like this. We have an int I is less than nums dot length, I plus plus. Then we'll have an int j, which is equal to I plus 1. J is less than nums dot length, j plus plus. So here, what we're basically doing is we're iterating through it. So for example, with the I, let's say this was the first iteration, our I would be a 2, and our j would be the 7. So first iteration, we have a 2 and a 7. We can check. So the first iteration actually works, but let's say this was like some other number. So we could check 2 and a 7, then j would increase, so we would check 2 and 11, then it would increase again, so we would check 2 and 15. Then we would increment the I. So I would turn into 1, which is 7. So then we would check 7 and 11, 7 and 15, and then I would increase one more time. So we would check 11 and 15, and then check if any of those work. So with that, we can just basically easily do an if statement to check if it works, if it's a valid solution. So if nums of I plus nums of j is equal to the target, then we can just return our two indices, which is I and j. So it doesn't want us to return the elements, so it doesn't want us to return 2 and 7, it wants us to return the indices, which is 0 and 1. So we can just do that right here. We can check if those two elements, so 2 and 7, if they equal the target, which is 9. In this case, yes, it does. So we could just return that. And basically going through it, if we don't find any, we can just return another, basically, a return value of just -1, -1. Here, we technically don't need this since it says that there's exactly one solution. So one solution will be possible. So we don't need this, but if we try to like submit our code without it, it'll say there's a return statement missing. So we can just put it in and check if it works. There we go. So check if it works. And yeah, it does. So we can submit it. And we can see that it got accepted. However, it is pretty slow. It takes 91 milliseconds to go through all the test cases, and like I said, it's O of n squared time complexity. And this is our brute force solution after all, so it's expected that it will be pretty slow. So how do we optimize it? In fact, it says right here, follow up. Can you come up with an algorithm that is less than O of n squared time complexity? So that's what we're going to do. We're actually going to go through an O of n. We're basically going to go through it in linear time complexity. So what that means, we're just going to have to, worst case, we're just going to have to go through each element once. We don't have to keep iterating over and over again. So we'll just need one for loop that goes through basically the entire integer array once, and by the end we'll have found our solution. So we're going to do that by using hash maps. So if you're not familiar with a hash map, basically we have a key and we have a value. So it basically assigns like two numbers, so in this case two integers together. So they're basically come together. We have information about them since they're together. But basically, I'll go write the code and I'll explain how this all works. So okay, so done writing the code, and basically the way it works is that it's better if I explain how this works first. Let's just go iterate through it. So let's say it's the first iteration. Num's I is 2 in this case, because I is 0. This if statement is not going to really matter that much if it's our first iteration, but basically at the end, we're going to put into our map, we're going to put in a target, which is going to be target minus num's I. So in this case, target is 9 minus num's I, which is 2. We're going to put in a 7, and we're also going to assign it to its index, since we're going to have to return the index anyway. So if we just assign it with the index, we could just quickly grab that and return that. So what this does is that going through the second iteration, when I is equal to 1, num's I will be equal to 7. We're going to use this if statement. If map.contains keys, so again, like I said, this is the key right here. Does this whole map contain a key, this key, which is num's I, which is 7? And in this case, yes, it does. We just put it in. With our 2, we did target minus nums of 0, which was 2. So 9 minus 2, we put in a 7. So in this case, yes, it does contain that, which means if we do find that it contains it, then that means that we found our two elements, since they'll complement each other to equal this target. So if this if statement is triggered, then we know we found our solution, so we can just return this right here. So we'll get the value that is assigned to it. So in this case, that would be this value right here when we originally put in the 2. So we had the target 9 minus the 2. We put in a 7 and a 0 because at that point I was equal to 0. So that gave us the index of our 2. And then we could just put in the index of our current value, which is I is equal to 1 or num's I is equal to 7. So we can just put in the index of 7 and then we can just return that. So the reason why this is great, the reason is mainly because of the hash map. So hash maps are great because unlike an array, if you're trying to find an element in an array, you're going to basically have to loop through that array, which is going to be O of n time complexity. Like if we wanted to find does nums contain 11? Then we would have to do a for loop, basically look through it, be like, 2, is that equal to 11? No. Is 7 equal to 11? No. Is 11 equal to 11? Yes. But you can see that we're going to loop through that. Hash maps, on the other hand, have a constant time complexity lookup time. So basically, instead of O of n lookup, we have constant time lookup. So it's way, way faster. So that's why basically having it like this is much faster than if we basically did it with an array. So that is why this solution is O of n time complexity and is so much faster. So you can see right here, we got 1 millisecond time, and that is faster than 99.75% of all the Java submissions for twosome. So you can see we went from, what was it, 91 milliseconds to all the way to 1 millisecond. We cut it down substantially. And so that was twosome. So if you liked it, you could subscribe.